All right, good morning. Hopefully you guys caught that last hour bit from Callum talking about his DX Commander antennas. I slept in a bit, I'll admit that. I slept in, so I didn't catch the beginning, but team replay for the win. Good morning, and welcome to the Saturday bit for the Ham Radio YouTubers Hamfest. And we're going to kick it off here in just a second. And just kind of, Callum's wrapping up right now. And he had a good show. There he goes right there. And appreciate him being part of the YouTubers Hamfest this year. So thanks much for that. All right, so I'm just going to go ahead and kick it over to Scotty here. He is Scotty Cowling. He is part of the TAPR, the Tucson Amateur Packet Radio Group, active in the TAPR DCC every year, and active in the TangerineSDR Project effort for the personal space weather station. He'll tell you all about that. There's some very intro videos on my channel about this project that you can go back and watch. If you just search on YouTube for TangerineSDR, I think I have the only videos that are up there about it. So, but we'll see how that goes. So, all right, let me unmute all the things. Scotty, good morning. How are you today?
Good morning, Jason. Doing great. A little early for me, but out here in Arizona. But hey, you know, we're here.
Yeah. If we were at a real Hamfest, we'd all be up by now anyway. So
we'd all be up by now anyway. I would have had all the bargains bought already.
That's right. That's right. That's right. Yeah. So, all right, man. I will kick it over to you, and I'm looking forward to the presentation. So thanks for being here, and the floor is yours.
Okay. Thanks, Jason.
Yeah, you bet.
Good morning, everyone. So really morning here in Arizona, about 5 a.m. So we're pretending it's a Hamfest day. Oh wait, it is a Hamfest day. So just because it's virtual doesn't mean we don't have a Hamfest. So anyway, I want to talk today about the TangerineSDR project, which is I think is an exciting new modular open source software defined radio, and it's kind of starting out targeting the ham side personal space weather station, and kind of morphed into a general purpose SDR with several targets. So we'll get on with it. If I can get my screen to advance here. There we go. So like I said, it's modular open source. Everything's open source hardware. Everything's open source software. And we're going to develop different components of an SDR. And it's also a group of volunteers led by TAPR and HamSci to some extent. HamSci is amateur scientists, and they're really good on the science end of it, but they're not so much radio people. And of course, the TAPR people are radio people, and we're not scientists. So we're kind of merging the two groups together to get some synergy and build a new radio that will satisfy the needs of the HamSci community. And we do acknowledge the support of the NSF and also the Amateur Radio Digital Communications corporate. I don't know if it's a corporation, it's a foundation that provides grants to worthy projects, and we've been deemed worthy. So they're helping us fund the prototype boards that we're going to be building here imminently, just within the next month or so. So what's a TangerineSDR? Designed to appeal to the most people, most audiences as possible. You can configure it from, I mean, we're hoping we're going to get it as low as $300. The production costs are yet to be determined, but if you want to fully configure it with high performance pieces, you'll be able to spend upwards of $1,000. Probably it'll be under that $1,000 limit, and based upon open source model, TAPR OHL for hardware and GPL for software, and extremely modular and configurable. And it started out, we were looking for something that would satisfy the HamSci people with an off-the-shelf SDR that we could just point them to and say, here, go buy that. And we looked around and we really couldn't find anything that had all the features and capabilities that they needed. So we decided to roll our own. But it really helps when you roll your own to make it appeal to a broad base of customers, if you will, of users. Okay, so there's 4 basic components to the TangerineSDR. The baseboard we call the data engine, and I'll get into what's on each of these boards, but it's basically kind of like a motherboard with 2 RF module slots on it and a clock module slot. And we also have what we call a leaf slot, which is basically a Raspberry Pi hat connector. So you really can add 2 RF modules, a clock module, and a leaf module to the data engine to have a 4-board set. And in addition, what we do is we pair that 4-board set up with a local host computer, which typically is a single board computer, like Raspberry Pi or an Odroid N2 or whatever. And I can tell you the rationale behind that is originally we thought, well, we'll put an FPGA on the data engine that has a onboard ARM core, dual ARM core. But in order to do that, it adds about $100 to the cost of the board, just for the chip that we buy that supports this. Plus, you've got to put more RAM on there. You got to support the operating system with hardware. We thought, well, I can buy a Raspberry Pi for $35, and next year I'll be able to buy a Raspberry Pi 5 or a 6 or whatever comes next. And so maybe it's more expeditious to just use off-the-shelf boards for the local host and not try to duplicate an inexpensive single board computer on our board. So that's the way we decided to go. So here's the model of it. You can see on the left the data engine with the 2 RF modules, the clock module, and we include a 3-port gigabit E switch, one that goes to the FPGA here, and the 2 external ports. One goes to the single board computer, other one goes to your local network in your house or your business, wherever. It's the port to the external world. And you can see by pairing up our hardware with the single board computer, we kind of make a different kind of arrangement than just your normal everyday SDR. And it gives us a lot of power because a lot of the networking is done by the single board computer, and we don't have to mess with any of that. We run Linux on it. We get all the networking stack for free. We get the security for free. We get updates for free. It just makes a lot of sense to draw the dotted line, if you will, around both of these boards. And that single board computer, that is, you're not going to be checking your email on it, okay? It's a dedicated processor that runs the data engine. Okay, so what are the hardware features? Gigabit Ethernet, and this is a direct sampling receiver, so we hook the antenna to the A to D converter basically, and frequency coverage from 100 kilohertz to 60 megahertz continuous coverage. Web-based configuration, because remember, we can run a web-based server on the Raspberry Pi, and we can configure the hardware via the Raspberry Pi, so it's going to look like you're going to take your web browser and you're going to configure the radio with your web browser. I think that's similar to the Kiwi SDR. They have a web browser for their configuration interface. You'll be able to generate multiple UDP streams of data from the data engine directly out to whatever IP address you would like. So basically the Raspberry Pi sets everything up, and then the data engine just streams the data to the destination that the Pi has told it. We also added a USB 3 interface, which is a 5 gigabit bidirectional, single lane bidirectional USB 3 port. And we don't really have a specific use for that yet, but it was so easy to add. I thought, well, we'll be one of the few radios that actually has USB 3 and gigabit Ethernet. And we added a USB 2 in order to be able to take like an RTL dongle, the inexpensive $20 dongles, plug them on here, and you'll be able to take the data and do processing on it with the FPGA that you can't really do with the Raspberry Pi or a host computer when you plug that dongle in. So some interesting new capabilities will become apparent here. Right now, it's going to be receive only. Transmit is definitely in the future, but the first application is for receive only. So this is a kind of an overview of the way the hardware plugs together. So if you can see up here, the blue are the 2 RF modules that you can see at the top and the bottom. They kind of stick out from underneath the data engine. And these are SMA connectors. And these are 2 identical slots. So we'll be building the first RF module. Will fill one of these slots, and this will be reserved for another. You can put another RF module in there if you like, or a transmit module in the future. Then up here in the upper right is the Raspberry Pi hat board. And what we've done is we've extended it with a high-speed, additional high-speed lines outside the envelope of the Raspberry Pi hat. So you can plug a standard Pi hat in here and get this I/O, low-speed I/O, or you can design a special board called the Leaf that will have this extra tab on it, and then you get access to some more voltages, and you get some access to more power, and you get some access to some high-speed I/O. So that's a kind of a hat board on steroids, if you will. Then over here in the corner, in green, is the clock module. And this is kind of a rough depiction. There's just a very small notch out of the corner to accommodate the Leaf board. But this board has an onboard GPS, and one of these SMAs is for an external GPS antenna. So you can get extremely accurate frequency and time measurements using this GPS TO board. And let's see, what did I forget? The FPGA is here, and the data engine is the black outline here, which is kind of like the motherboard that holds the RF modules and the clock module and the Leaf module. And this is a stack of 2 RJ45s. So one will go to the local host, one will go to the external world. Okay, on the TangerineSDR data engine, we're using an Intel Max 10 FPGA. This is the largest one that they make, and it's the fastest one they make, and it's the widest temperature one they make. So it's really the Cadillac of the Max 10 family. 50,000 logic elements. A logic element consists of a lookup table and a flip-flop. So you can see there's lots of resources in this part to do what you want to do, things that you want to do. We also added RAM and 2 types of serial flash memory. Serial flash memory is going to be used to hold perhaps additional images for the FPGA or filter coefficients or whatever, and program memory for an onboard soft-core microprocessor that we're going to put inside the FPGA that's going to do the housekeeping features and manage the Ethernet and things like that. Oops. Sorry, got carried away there. Okay. Also a micro SD card. This may be used for updates, although we're planning to do updates over the Ethernet, so you will not need to have anything special. Be able to do it via the web. Okay, the power supply is 11 to 15 volt wide input, so you can use your station power supply for that. And as I mentioned, a 3-port gigabit E switch. We're also going to have a crypto processor with key storage on board. We get a unique serial number for every data engine so that they can be identifiable uniquely online. That means we can give, we can modify the the default MAC addresses so we can make everyone a unique IP address or MAC address. And the idea being, I want to be able to put plenty of these on one network, so they can't all just be programmed with one MAC address. Now, typically when you buy a development board, they all have the same MAC address, but that's not going to be the case for us. Okay, so this is a preliminary layout of the data engine, and you can see up here is the Raspberry Pi header or hat, and then this here down here about halfway down is the high-speed interface, M.2 interface. We use the same connectors that solid-state drives use because they're high-speed and they're very inexpensive. And then over here you can see the clock module. This is an earlier version because it doesn't have the extension out. We actually extended the clock module out this way because we needed more room. And to give you perspective, this board right here is 4 inches across and 4 inches high. So it's a little bit bigger than a Pi, but not a whole lot bigger than a Pi. And it's hard when you're working on it to keep that in perspective because you think, oh, wow, look at all I have to run FPGA IO all the way up here. Well, that distance is like 2.5 inches. So it's really not very far away. Nothing is very far away from anything on this board. So, and since it's modular, we've opened it up for future data engine boards with larger and faster FPGAs or more RAM, or maybe a real SSD port, or maybe since we're using Ethernet, it scales to 10 gig E, 40 gig E, etc. But the same ports, if we keep the same ports, you'll be able to reuse your RF boards and your clock module. And that's not trivial because those boards are not inexpensive either. They have high speed A to Ds on them, the RF boards do, and the clock module has that expensive or could have that expensive GPS if you choose to buy that module. So let's get into a couple of the features of the other modules. The first module, receive module, we're going to make is for the personal space weather station, which is the first use case. And I'm going to get into that in a minute here. But it has a dual 125 megahertz, 14-bit ADC on it, and a switchable attenuator, a 20 dB amplifier. And what I find most interesting is we have a fixed 55 megahertz low pass filter, but you can remove that. So if you want to use the board and undersample and feed in higher Nyquist zones into it, you can take this filter off. And we provide a user-defined plug-in filter, just headers that you can design your own board for. You can build filters for any frequency band that you want and use this board for undersampling. And we actually have a use case for that in the ground station for phase 4 for the geostationary satellite. We have an onboard calibration noise source that you can switch on and off, and onboard low noise power supplies, which means that they're more or less independent of your lab supply, of your station supply. We regulate the power off of that and filter it, so we get very low noise local power supplies. And these ADCs are synchronous, so you can use this as a diversity receiver with the 2 SMA connectors, or if you plug 2 of these onto the data engine, you end up with 4 channels that are all synchronous, and you can maybe do things like antenna steering or other cool diversity type tasks. This is a block diagram of the receive module, and you can see RF on the right flowing to the left. This is kind of backwards. It's a right to left kind of flow. Attenuators, filters, the low pass, removable low pass filter, 20 dB amplifier, dual ADC, and then the digital interface that goes to the data engine on a 140 pin M.2 connector. This is similar to the SSD connector, only it's got 140 pins instead of 75 pins, so it's big. And this is a layout of the board. This board is completed. We are waiting to build it because I think we're going to end up having to make a few modifications to it because of issues we had with the data engine, which I'll get into in a minute here. But you don't really want to build up a bunch of these and then find out, oh, gee, I had to change the pin out of the connector because of a problem on the data engine, a routing problem on the data engine. So you really want to wait until they're all ready and then pull the trigger and build all of them at the same time. So the first application is the personal space weather station. And like I said, I'll get into that in a minute. We're also talking about an additional module, either an RF module or a leaf module for VLF to cover 10 kilohertz to 200 kilohertz. So you'd have a complete 10 kilohertz to 60 megahertz solution with one stack of boards. And you may need a different receive module, and you certainly will need a transmit module for the phase 4 ground, because it's a 5 gig up, 10 gig down kind of thing. So you need a 10 gig receiver. So you use an LNB or something. And again, I'll get into that in a minute here. And maybe some line. I mean, the limit is how much design time do you have? How many people do you have working on it? The idea is to make this a platform that will be usable for multiple uses. So I'm looking forward to having multiple RF modules, different ones. Now we move on to the clock module. We're going to use a Vectron TX801. This is an amazing clock, but nothing comes for free. It's a little expensive. But the amazing thing is, this spec here, right? The holdover stability. So when you lose satellite lock, if you keep the temperature constant on this TCXO, it gives you 40 parts per billion. That's 0.04 parts per million of stability on the oscillator over a 24-hour period. So that is an amazing stability figure for such an inexpensive oscillator. And it has very good phase noise output, as you can see here. And we're going to pair that with a U-Block ZF9T. And what we've done is we've put 2 footprints on the clock module, so you can use these high-performance F9T. That GPS costs about $180, but it's a dual-band GPS, so it's going to allow you to do a lot more scientific measurements. But not everyone needs a $180 GPS, so we made the capability to use a $50 GPS, use the alternate footprint. So we'll have 2 manufacturing builds of this. The high-end one, I guess they call it the platinum version, and then we'll have the gold version, and then we'll have the silver version, which has an even less expensive, it's about a $20 GPS. And as you go down in price, you go down in capability. So, but again, you match what the hardware that you buy to the capability that you need. And then we have a multi-channel synthesizer, and basically this clock module supplies clocks to both RF modules and the Leaf module and to the FPGA. So everything is synced up together off of one master oscillator. And again, this plugs right into the data engine. One feature that we're going to have too is that you'll be able to buy from TAPR a optional carrier board that you can plug the clock module into that will give you a near laboratory grade standard for your shack. So if you want a high stability 10 megahertz output, or if you want a synthesized output at a particular frequency that's phase locked to that 10 megahertz, you can use this board, plug it onto the carrier board, and basically this carrier board becomes another use case for the clock module. So it fits into our modular, everything's modular and fits together kind of philosophy. This is the block diagram of the clock module. See the oscillator up here. We have a jitter reducing part here, and then the synthesizer, and you've got 10 outputs that are connected up to the M.2 connector. And again, this is the same kind of connector that we're using on the Leaf board that SSDs use. Very inexpensive, very high speed rated. This is the layout of the clock module. And keep in mind, this module is like that big. It's like 1 inch across. So this is a blown up giant view. This GPS, I think, is 17 millimeters on a side. So actually that puts this a little over 2 inches, I guess, across. But still 2 inches square, very small board. And I believe this is going to be, this is already laid out. This is a 6-layer board. The data engine is going to be 10 layers. And the lowly RF module is only 4 layers only. So high performance, dual band GPS, or a mid-grade performance, or a low-cost performance. These are the 3 manufacturing options that we will offer on the clock modules. Starting out with a high performance one because we need that for the personal space weather station. We need the dual band GPS performance. Okay, on to the Leaf module. I'm getting a little close on time here. So the basically, I explained this before. You've got the low speed IO here. So you can accept a standard Raspberry Pi hat. If you want to design a specialized Leaf board and you need higher speed IO, you can get it off of this M.2 connector by just making your board a little bit bigger and having it plug into this connector on the data engine. These 2 connectors are on the data engine. We defined the pins on this to match the Raspberry Pi. So you can use, maybe not every Raspberry Pi hat, but you can use most of them. So this is an eye chart. I'm not going to leave this up here very long, but I want to put it in here so that you can come back and look at this as a reference. I went through and kind of enumerated all the features of similar boards to what we're building, and it's just pretty hard because a lot of features are left out on this chart. So I mean, if you want to just put these in monetary order, that's really not going to give you the answers that you want probably, but it gives you a list of similar boards that you can go look at and look at the feature list they have and see how they match up to what you want to put together. So what can I use it for? The important part. The Hamsci Personal Space Weather Station, that was its initial target. Phase 4 ground, we're talking about using it. They're building their own receiver, but we may be able to use this for some applications for the geostationary satellite. Academic uses, like the type of things that a red pitaya would be used for, although we tried to steer around some of the red pitaya problems. Amateur communications SDR, like an HP SDR, if you're familiar with it, or Hermes board, if you're familiar with those projects that have been ongoing since about 2006 and are very mature. And we learned a lot from those projects, so we try to fold that into this project. Also experimenters, amateur and non-amateur, even the scientists will be able to experiment because it does such wide band receive coverage. And remote ham radio, of course, that's a biggie. I think there's someone talking about that later today, in fact. Anyway, others maybe that we haven't even thought about yet, haven't come up with. So this is the personal space weather station kind of a feature list. All the things that you can do. You can run reverse beacon network. You can run Whisper. You can run. You can monitor. And remember, we have only a receiver, so you can monitor FT8, characterized ionospheric noise. This TEC, total electron content, this is it arrives because we have a dual band GPS receiver. With the VLF module, maybe a lightning detector or a TID detector. So basically space science. Okay, and then if you move on to a different view of the same thing right here, there's your client computer down here. This is more hardware centric here with dual antennas, a magnetic field magnetometer, a pretty good one actually that we built just for this project that compares favorably with multi-$100 units and it comes in at about $60. And this would be the phase 4 ground station. So you take an LNB and you would down convert it and feed it into the receiver and undersample it. Okay. And then for the PA, you'd up convert, you'd generate a baseband signal and up convert it in at the feed point, most likely, because you're talking about a 5 gigahertz transmitter. So you're not going to put that at the end of much feed line. So this is a possibility. HF experimenter, you might use the mid-grade oscillator that doesn't have a GPS in it. And you might use a more premium receiver, a 16-bit receiver, and then the transmitter that we're going to be designing here coming up soon. For a low-cost version, there is a capability to clock the RF modules without using a clock module at all. So you get lower performance, but you get a lot less cost. So this is one of the options. And maybe use a 12-bit ADC at 80 megasamples per second. We built receivers with those kind of ADCs, and they work just fine for your low-cost applications. So what can you do with it besides personal space weather station? Well, the cool thing is since it's direct sampling and it runs inside an FPGA and generates data streams, these things can all be done in parallel. Now we have actually written code for a Raspberry Pi to emulate the data engine right now, so they can continue to develop software even before we have any hardware. And Bill Angelke has built Whisper monitor and FT8 monitor, so you can put a call sign in, and if you hear your buddy on any of the bands. Now remember, we listen to all bands at once, so you can listen to all bands. And if you decode the FT8 stream, and if you hear your buddy on, it can send you an email. Because remember, we got a Raspberry Pi, right? So it can send you an email. Hey, Bill's on 30 meters, and here's the frequency, and here's the last time we heard him. And we'll be able to do full digital modes once transmit is implemented. So just a quick blurb. I've got about 1 minute left here. TAPR's mission to support digital radio development with R&D funding. And again, we appreciate the ARTC funding that we got, a grant we got. That grant was to TAPR to build more prototype boards. So we'll be able to distribute them amongst a little bit bigger group of people. So anyway, we get a growing pool of contributors. And if you stop by our session on, I'll get to that in a second. Our session on Monday night, you'll see we have 20 to 30 people every week that get on and talk about this and about their development, their tasks and their successes and their problems. Also, if you like this conference, this is a great conference. There's a TAPR Digital Communications Conference in September. It'll be a virtual Zoom webinar similar to this, and it'll be maybe a little bit on the more technical side, but a lot of fun. So come look it up, tapr.org. And here's our weekly Zoom meeting every Monday at 9 p.m. Eastern time. And the information is on our webpage, TangerineSDR.com. And feel free to subscribe to our email listserv. And again, the instructions on subscribing are on the webpage. And how did I do, Jason? 30 minutes?
Did just fine. Yeah, that was great. Thank you, Scotty.
You're welcome.
That looks good. I've been watching this project since its inception, and I'm planning on picking one up as soon as they're available and doing some tinkering with it myself, and of course doing videos on it because I think it's a fun project. So the only question I really saw in the chat was somebody asked, is it going to be running Tomcat or Apache for the web server? Or
Haven't
have you
really
decided that?
haven't decided that yet. It
Yeah,
could be
okay.
either one.
Right. Okay. All right. Well, maybe that's even something that each individual end user could use. I don't
It
know.
could be. In fact, we were planning to support several single board computers because
Right.
while the Raspberry Pi is kind of the de facto standard and very inexpensive, there are some much higher performance boards out there for just a little bit more money. But we can't support everything, but we'll pick
Right.
2 or 3 maybe and support
Right.
those.
All right, man. Well, thank you. I appreciate it a lot. I'm gonna switch over to our next guest, but I did share the link to TangerineSDR.com in the chat, and anybody who wants to know more information about that project, check out those links there that Scotty's got, and check out the website I linked in the chat. So 73 Scotty, and good morning. Thanks for being here this morning. So
right.
I know it's really early for you, so a special thanks for that.
Well, thanks, Jason, for the opportunity.
Yep. Have a good one, man.
Great job.
Oh, thank you. Thanks a lot. Okay, let me do some switching around here. And let's see, waiting room. There, we're going to switch over to that. And I want to say good morning to Don Izzo, Smoke Signals RF. He's coming up next in about 30 minutes. Steve Good Game's in the house. Good Game Ham Radio. And who else? Who else is in there? Got Oklahoma Ham Radio in there. Good morning, everybody. Thanks for being here. And let's see. Okay, Bob, I think we've got you in there.
Hey.
Hey, good morning. How are you?
Good. Can you hear me?
Yeah, it's a little quiet, but I can hear you.
Is this better?
Yeah, that's better.
Cool.
So what's up, man? How are you this morning?
I'm good. I've been trying to get this new computer together today, and I think we got it finally. So
good.
I'm not laggy anymore, right?
No, it looks okay right now.
Good. That's great. Hopefully we'll stick with it.
Good. Okay. So tell us all about RFinder. So kind of like a Hamfest blurb. That if you were standing at a booth right now and someone walked up and says, "What is RFinder?" Start from there, because a lot of people might be new to it for the Hamfest, and just go from there.
Sure. Well, we started RFinder as a repeater directory about a dozen years ago, and as a worldwide repeater directory. And about four and a half years ago, I was approached by DF200, and he was calling me actually from Singapore saying, "Bob, you have to fix this code plug problem." And I started to try to figure out, how do you generate code plugs from the database? And then I had an epiphany one morning. Why don't I just make an Android radio, and problem solved? So we started looking for platforms to do that. At first, I tried to figure out how to make one, and then I looked for platforms that were already being made, and see if we could adapt our software and modify the ROMs and stuff. So that's what we ended up with. And we're up to the 4th generation. This is the B1. So it's no code plugs ever. It works anywhere on Earth. You just pull it out and it works. And I can tell you that as somebody who's tested it all over Europe and all over the United States and South America, and just everywhere you go, it just works. So it's a lot of fun.
I took it to Costa Rica last time, whenever that was, 2 years ago, and it worked there too. So
isn't that beautiful?
There's not very many repeaters on the VHF UHF bands in Costa Rica, but not in the area we go to anyway. There's some around San Jose area, but that's not where we were. We were up farther north than that. But yeah. At least I could scroll down and see, 150 miles away, here's a repeater.
Nice. Well, my son and I actually went to Costa Rica about 6-7 years ago with Yoda. And actually, I'm sorry, with the YDXA. and we had a great time. I mean, really, really great time. Great bunch of people, and I think they've moved now. They're not going to Costa Rica anymore. They're going somewhere else in the Caribbean. But good group. Had a great time. So, but like, I can land anywhere. I've landed at Heathrow and opened up the machine at Heathrow GB7 LHR, and then drove up to the National Hamfest in England and just opened up the machines as we were driving along, and no problem. Works great, beautifully. Dallas, I've been to, I've been visit you many times, but
Oh yeah,
it works great down there in what I call DMR Central on Earth. You guys seem to have more DMR down there than anywhere else. It's kind of cool.
Yeah, there's a lot of DMR here, so
Yep.
it's fun too. But so you're
Yep.
going to Israel next month.
I am. I'm going to Israel. They just opened up individual travel for July 1st. They opened up this month group travel.
Ah,
So
okay.
so I like to go visit. I stay with 4Z5 Oscar Tango in Netanya, and he calls his guest room Bob's room. So I go there quite a bit.
Nice.
Now, whenever I'm in Europe, for Hamfest in Europe, I make my return from Ben Gurion and go visit for a bit. And we go scuba diving and play with the radio and stuff. And I like to go have there's a Tuesday morning breakfast in Haifa with a bunch of old hams that get together up in Haifa. So I like to go to that on Tuesday mornings. I get my whole shtick when I go there. I do my rounds, and it's a lot of fun.
Yeah.
Go to just south of Jerusalem. There's a place called Caliber 3 that we like to go to, and do a little bit of counterterrorism training. So,
That's fun.
it's great. It's great fun. It's a lot of fun.
Yeah, that sounds like, you told me about that last time you were. That did sound like fun.
Yeah, actually, I think I'm gonna do tactical driving training this time.
Oh wow.
They got a tactical driving training day.
It sounds, in Israel, no less. That ought to be really fun.
That's a great place to do it.
Yeah, no doubt.
Yep.
Sheesh. So you've got. Do you have any samples there you can show us? Because I was going to ask you about your new HCP cubed, or whatever you're calling it. Is it squared or cubed, or what is it?
It's going to be the HCP cubed. It's not quite here yet. It's on the way. I have an early prototype. I can just show you what the case looks like. It's going to look roughly like.
That's okay.
It's going to look roughly like this, and it'll be a. I call it cube because it's a battery bank. We're not sure if it's going to be 14.5 or 12,000 yet. Pi-Star with an LTE module. So this thing will be its own on-ramp. It will not need to connect to a Wi-Fi to get out, and it will also act as a Wi-Fi access point. So that's why we call it cubed: Wi-Fi access point, MMDVM, and battery bank.
So you basically be able to take your SIM card out of your hotspot, out of your Wi-Fi hotspot. Now, I've got my extra SIM card actually in my RFinder P2 tablet right now.
Nice.
And then I just share the internet to whatever device I'm on. But you'll be able to take a SIM card, put it into this device.
You mean the P2?
Yeah, the P2. That's it right there. So be able to share, and from this device, it'll allow Pi-Star to get on through the SIM card, but you'll also be able to do Wi-Fi sharing, so you'll be able to get all your other stuff on there as well.
Right.
So
to be able to stick that in your car, and it'll be your Wi-Fi on-ramp for your car, as well as your radio on-ramp and whatever. So it won't require any kind of Wi-Fi connection because it'll be its own. It'll have its own upstream. So.
Right. Yeah, that's I've not seen anyone do that yet. The original HCP one had its own battery, has its own battery, and that was the first time I'd ever seen a battery powered Pi-Star device. So
I think it's still I think it's still the only one.
I don't think I've seen the OpenSpot 3 has a battery, but it doesn't run on Pi-Star. So that's the only Pi-Star battery powered device that I've seen.
Yep.
And I still use mine. I've got it up here, and it works quite well when Brandmeister decides it wants to work. But it does it connects to TGIF beautifully. So Works good. Cool.
Yeah, we're
What?
actually. I'm actually talking to Ty about adding some stuff to TGIF. So
Yeah.
something we're in the middle of beta on the B1,
Hmm.
soon to be on the pad is DMR over IP. We call it DMR ROIP, DM
Hmm.
ROIP really. Um, and pretty soon you'll be able to. You can do it now in the beta, and I think you've played with it.
Hmm. Hmm.
You can get directly onto Brandmeister if you can't get to a repeater. It is its own hotspot.
Right.
But it's not a hotspot like in the traditional sense where it'll repeat a signal coming in from another radio. It goes directly as an end node to Brandmeister, and it's literally a one-click switch between RF and IP. So
Yeah, and it does work. The beta does work quite well, actually. I had a 30-minute conversation with Howie when I was up there. I was sitting on the ferry going to Connecticut to visit W1FYG, who's in the chat right now, and I was just sitting. It's like an hour and a half ferry ride, so I got on there and I was talking to it, and it was this was like 2 or 3 or 4 versions of beta earlier than the one that's out now, and so it had some drops and misses and whatnot. But the beta that's now I've found to be pretty solid. So I'm looking forward to seeing what the production release is going to look like on that.
yeah, well, we're getting warmer,
Hmm.
and I'm getting laggy, aren't I?
Yeah, you are.
Oh yeah. All right. Well, I'll tell you what. Let me just switch over. It won't be as pretty,
Yeah.
or yet maybe it is. I don't know. So
Oh, that's much smoother. So there you
yeah,
go.
that's
Whatever you changed.
Caesarea in Caesarea in Israel,
Ah.
between
Okay.
Tel Aviv and Haifa.
Yeah. So yeah. So Bradley Forrester must be a beta B1 beta tester. He's in the chat saying Roy works great. So
Awesome.
it's a good deal.
Yeah, no, it's really a lot of fun, and uh, we've been working. This is our fourth iteration. I mean, it took us
Hmm.
four tries to get this right, and uh, the first three we were playing with a software codec similar to what uh, uh, DroidStar is using.
Mm.
Um, but we found that we just could not get good quality audio, and the audio coming out of this now is stunning. I mean,
Hmm.
it's really sharp. As you know, it's really quite
Hmm.
good.
Yeah.
Um,
It's hard to tell the difference between that and just a normal hotspot that you're listening to.
it's actually it's actually easier to tell because it's crisp.
Yeah.
I mean, literally, you can tell that it's Roy because it's very clean, and we're actually using the RF module in the device as a coprocessor to do the encoding of Ambi2. So that made a big difference, a huge difference by doing that. So it was a bit challenging to make it happen, but we made it happen. So took a lot of ROM updates and back and
Yeah.
forth between the ROM and the app, and we finally got
Yeah.
something that worked. So quite nicely.
Cool.
Yep.
Well, you showed a picture of a P2 a minute ago. Why don't you tell us about that one?
Sure. The P2 is a um, is roughly the same guts as a B1. Uh, do I have noise in here?
Something, but it's barely noticeable on my end.
Oh, sorry.
So,
Actually, it's probably my P2.
oh, that's probably
Um,
the P2. Yeah,
yep,
it wants to talk.
actually. Yeah,
Yeah.
actually, it's got a prototype of the original software codec. So I'm just going to
No.
shut that off. So anyway,
So the P2 is a tablet where the B1 is a phone.
that's correct. So it's I normally have this mounted in my car.
Mhm.
So I use this as my mobile, and I have it attached to a Diamond SG7900, which I just think is the hottest antenna out, and it's been so hot for a long time, and it's loud, it's bright,
Mhm.
so
Mhm.
it's a nice antenna. So that's what it looks like in the car. I don't have a GPS right now because I'm indoors and I just fired this up, but
Mm.
normally you would have the list of repeaters here on this side,
Mhm.
you know.
So is it the device uses the GPS module inside the Android device to tell you where you are, of course, like every other Android phone does. But then it
Correct.
shows you a list of repeaters that's close to you that you can connect to automatically with one touch, be it DMR or analog both. So
Yep.
2 meters, and 440. Pretty cool.
Yep. So you don't have to, you don't have to make a codec for it. It just works
Right.
anywhere you go, man. It just
Mhm.
follows you. So it's pretty cool. You don't have
Yeah.
to you don't have to mess with it. It just works. You just pick up the mic and start using it and look, see what's around you and whatever. Let it rip.
Bradley says again in the chat, it's kind of funny sitting here and watching the two biggest spenders of my money. Hi. So hey,
Yeah,
bud.
well, that's
Yeah,
how it goes.
we appreciate you watching, but no one's forcing you to. But don't stop. So, it's
Well,
all
you
good.
and I both work around the clock, so I think
Oh,
we're
yeah.
entitled. I think we're entitled to spend. I don't know. Maybe I don't know.
I don't know. I just tell people where to go shop. They don't actually send me. I mean, I guess I do sell some T-shirts, but more than that, I just say, hey, here's a deal. Here's a deal. This guy's got a sale. So that's what everybody's always talking about. Fridays are my days where I spend their money. So
Oh, very nice.
it's all good.
Mhm.
But all right, cool. So we got a B1, a new hotspot that's coming, and a P2 that's out. The P2 has an external microphone for it.
That's correct, and it's
And
actually very loud. At first,
it is.
I thought I was going to have to come up with, and I have a splitter so you can have an external speaker, but we found that the mic is so loud that when you turn it all the way up, that you don't even need an external speaker.
Mm-mm.
It works fine. So I have the mic hanging, the mic hanging to my right, and it just does
It
a
is
beautiful
loud.
job.
I just don't care to have a speaker mic on a mobile radio. That's just something that's just a personal preference. So I'm planning to use the Y adapter on mine so I can connect one of my mini external speakers that I already have in the car.
Sure.
But that's just a personal preference. But it's nice to know that the option is there for either one.
It is. It's all
So
about choices,
yeah.
and that's what
Mhm.
that's really what we try to do in everything we do, is to give you choices on how you want to implement it. So
Very good.
Mhm.
Very good. Cool. Well, you want to tell us about the new? Speaking of the P2, you got an amplifier coming for it.
Yeah, we're working on that. It's a little bit slower than I wanted. We're working on a dual band TDMA amp. It'll work on any of the digital modes.
Yeah.
4 watts in, 40 watts out, and it'll have a preamp in it, so that because DMR is bidirectional, you really want to have symmetrical amplification. So we're working on an amp that has a preamp in it, and uh, 40 watts out,
Mm.
beautiful.
Makes
So
for a really nice mobile rig for sure.
yep, and it'll work with that one will work with any really any radio. So even if
Mm-hmm.
you have a MD380, quite frankly, you'll be able to plug it in. It'll be dual band. So
Mm-hmm.
2017, any of the newer ones, like this is actually kind of a cool radio, I think. A lot of you guys have these, but
Anytone, yeah,
yeah, the Anytones.
yeah. The Anytone's a good one.
Yep. So it'll work with those also.
Good,
hmm
cool.
Yep. And I'm working on actually, I have the prototype on the way here, the P5, which is a 10-inch version of this.
Ah, okay.
Yep.
You
It'll be
you have a prototype there already?
No, it's on the way here.
Oh, it's on the way.
I would
Okay.
show it to you if I had it.
Okay.
It's on the way here.
Okay.
Um,
That'll be fun.
I have a couple of prototypes. I have one that I don't want to talk about yet.
Okay.
But I have another prototype coming. And then this one here is a prototype. I don't have an antenna on it, but this has man 14 in it for
Oh, okay. For FirstNet.
FirstNet. Yeah.
Mm-hmm.
So
Okay.
this is working on FirstNet. See if I can. Yeah, here we go. I don't know if you can see. You probably can't see it.
It's a little it's a little
It
bright.
says FirstNet on it, but
Okay.
so we're working on this, and this hardware platform will probably end up being the next iteration of the B1.
Okay.
So, but it's a ways out. So
Yeah. Okay.
I still have to get this FCC approved and then get it approved by FirstNet. And there's
Yeah.
I have to throw a lot of money at it to make it
right. Yeah.
to make it approved. So
Well, the current V1 is a Part 90 certified device.
that's correct.
So you can use it on commercial bands as long as you have licenses to use it on other frequencies. It'll work on Part 90 frequencies. So it's full open transmit on 2 meters and 440 due to that.
Yep. And the new ones that have been coming out the last few months are 400 to 490. So
okay. So it went up a little bit from 480.
yeah, it went up. Yeah. Well,
Okay.
it was 470 originally. We brought it up to 490, and we made a little bit of a slight mod in the tank circuitry. So so brought it up to 490, and it's working quite nicely across the band.
Good.
So yeah, so that's good. It's getting there.
Yeah, for sure. All right, man. Well, I can tell you you haven't been awake very long, and neither have I.
What are you talking about? I've been up since 4:30 this morning.
Well, you act like you just woke up because you're usually a lot more energetic than
Woo!
You come onto the lunchtime streams, you're like, so.
Well, by then you gotta understand. By then I've had like a dozen cappuccinos.
Right. Yeah.
And
right.
I'm only on number 3.
Yeah.
And in the honor of this being a Hamfest, of course.
Waffle House.
That's so we have to pretend that we're in Xenia, so.
Right. Yeah. We want to eat at the Waffle House before ham
eat at the Waffle House. Yep. Absolutely.
Cool. Good, man. Well, hey, I appreciate you taking the time out. That's really good info. RFinder.net is the website where all Bob's devices are, and the Facebook group is just called what? RFinder
Android Radio. Just go into just search for RFinder Android Radio and you'll find it. And we're available at HR at Gigaparts and HRO, and we're also available at Moonraker in England. So we're having a great time. Good time of my life. So I appreciate everybody's support that's gotten a radio. Everybody seems to be really enjoying it. So
yeah, a lot of really good feedback in the Facebook group. People come in there with questions about how to do stuff, and it's a pretty open group to talk about. Oh, I've done this and done this, and I get in there and talk on it when I can. I don't get on Facebook every day, but I've been in there a few times to answer questions for people that I can't shoot. Sometimes I'm asking questions. I'm like, I found this thing that doesn't. I don't know what this is. So.
Well, it's got a lot of depth to it. So as people figure out new things, and every time we come up with a new update, it's like a new radio. So it's really kind of cool. I mean, you've seen it. We'll come out with an update, and all of a sudden it's like, wow, this is like it's like I just got a new radio. So
oh gosh.
No. I mean, think about it, right? I mean,
I mean, I mean, you add new features to it, and it's like, oh, it is like a new radio with features that weren't there before. Yeah.
I mean, it's very malleable. So and everybody's on the design team. I always say, everybody that owns one is on the design team. So we get a lot of feedback from the owners, and they're like, hey, what if you could do this? What if you could do that? And sometimes I'll come up with an idea and I'll throw it out to the group and and see what their take is. So so it's been a really great collaboration between my team and the owners, and we just keep making it better and better every day, and we're having a great time doing it. I'm having the time of my life, quite frankly, and and that says a lot because I've had a pretty exciting career in my in general. So being able to do this and do this with the hobby that I love so much, and I get to meet so many people every day. I feel like every day I make a pile of new friends. So it's just been really a lot of fun. So thanks everybody for your support.
Yeah, for sure. Yeah. RFinder.net on the web and the Facebook group. I'm going to tell, this doesn't have to do with RFinder, but we were talking about Parks in the Air the other night.
Oh man, we had a great time.
I was telling people that you were floored that I was working pileups at Parks in the Air when I was up there. You were like, it's like your DX.
No, it was awesome, man.
Yeah.
No,
because
because my son and I have this shtick. My son, W2EEO Jesse, he's 21 now, but he's been a ham since he was 9. And I was a single dad full time, and he and I have traveled all over the world. We've been to 13 countries together, and a lot of times we'll bring radios and set stuff up. And one of his things that he always loved to do was get on 20 meters and make a pileup.
Yeah.
Him being the focal point of the pileup.
Yeah.
So,
Yeah.
imagine this little 10-year-old sitting there,
Mhm.
working like, three contacts a minute and, and ripping them off and it's just been, it's a lot of fun doing that kind of stuff. So
Right.
going to do parts on the air, all of a sudden it was like we were on the other side of a pileup. Oh my
That's
God,
right.
what in the heck is going on here? You normally have to get out of the country for that. So,
Right.
so
Right.
highly recommended. If you guys haven't done Parks on the Air yet, it's really a blast. And, Jason and I, did you post any of our videos yet?
Yeah. So a couple of them.
Okay,
Yeah.
that's cool.
Frank posted one too. The one on the beach at Wildwood by your house. Frank posted that one.
Oh, that was cool.
And
That was a
yeah.
cool one. Yeah, that was fun.
Mhm.
We actually drove down the block from my house, drove down onto the beach, set up the
Mhm.
antennas.
Yeah.
That was a lot of fun.
Yeah.
So that's cool. And I'm looking forward to Field Day.
Yes. Absolutely looking forward to Field Day. Yeah, you're coming back out here again, aren't you?
Field Day, we're coming down to Dallas, and we're gonna smoke a brisket.
Mm-hmm. Mm-hmm. I think I found a place to get a brisket.
Oh, you did?
Yeah.
Come on, you're in friggin' Dallas, for crying out
Well,
loud.
I mean,
You
I
can't
want to
get a brisket in Dallas.
you can get a brisket anywhere, but I think I found a place to get a better than average brisket. I'll put it that way.
Well, make sure it's
So-
nicely marbled, okay? I don't want
Yeah.
any of that lean crap, okay?
Yeah. Right. Exactly.
Yeah, no. This has got to
Exactly, yeah.
really be an unhealthy brisket. It's got to be really good. So we're gonna have a great
Yeah.
time with that.
Cool.
So,
yeah. Yeah. That ought to be good. Okay.
with,
Let me.
with my own spin on what a Texas brisket is. So
It was good last time.
hey, well,
I thought it
thanks,
was
man.
good last time. I thought it was really good.
Yeah, except you
Okay.
didn't like my burnt ends, but I'm gonna do it the way you like it this time. So.
Oh no, I liked them. I just didn't like somebody put barbecue sauce on them. That's not my thing.
All right, well, we're
But,
not gonna do. We won't do that next time. We'll
okay,
just be on the
okay.
side.
We're almost at the top of the hour, and that means Don Izzo is going to be taking the reins here, and he's waiting in my waiting room, so I'm going to bring him on real quick. He's actually going to be talking about Parks on the Air in the next session for the YouTubers Hamfest. So let me bring him over here real quick.
Hey, Don, turn on your camera. Don.
He's there. He's connecting. It's saying connecting.
Are we gonna do three-way with Don, or am I leaving?
No, we're both leaving. He's going to take it over on his channel.
No way.
Yeah, we're doing this handoff thing all day long today and yesterday, and
that's
all
fun.
good. So
that's great. That is great fun.
So yeah,
I'm gonna go.
I'm
going to get the jet skis ready today.
Cool.
Going out into the shop.
Hey guys,
it's cold.
good morning.
Hey, there you are. No
Hey, Don.
video, Don.
Yeah.
Yeah,
You're videoless.
I'm wait.
He's probably using his video in his stream. So the countdown timer on Don's channel has started. So I'm going to share. It's the next one in the playlist, which is pinned to the top, and it should be there it is right there. So y'all go check that. I just linked the next video in the chat. So we're going to shut it down here, and we're going to move over, and we're going to listen to Smoke Signals RF talk about Parks on the Air.
73s, everybody.
Yeah, thanks, Bob. It was a good stream, as always, and look forward to seeing you next month for Field Day.
Fantastic. Bye, everybody.
All right. Later, guys.